Have you ever felt that programming languages are too esoteric and uncompromising? Did you ever find yourself wishing that programming could be as easy as texting to your pals? Well then, fear not. We, as part of Stanford Scholar Initiative, present a talk on the paper Naturalizing a Programming Language via Interactive Learning by Wang, Ginn, and others. In today's world, there is a significant learning curve for non-programmers to be able to perform complex tasks in a particular programming language. None of these programming languages incorporate natural language in their syntax, which could otherwise help these non-programmers perform better. Even though natural language interfaces do exist and have become ubiquitous, they are unable to leverage the power of programming languages. Moreover, in such systems, ambiguities exist between intended and performed actions. Thus, the authors strive to make this process easier for an average computer user.
Let's now see what makes this problem hard in the first place.
Natural languages can sometimes be ambiguous and equivocal. This is what makes programming in a natural language difficult. Doing so requires a large set of users with a wide range of user input to solve, which is often a daunting task.
Now let's have a look at some of the main contributions of the authors. To bridge the gap between programming and natural languages, the authors have introduced an interactive language learning process called naturalization. The authors show that through the process of naturalization, a programming language can be transformed into a more natural form. This makes programming easier for an average computer user. To illustrate naturalization, the authors created a core programming language called DAL and a virtual platform called voxellearn, which allowed users to build structures using the naturalized programming language.
Thus, voxellearn is a virtual world supporting a command line interface in which users can give commands to build complex structures using voxels. The users are allowed to either use the core or the naturalized programming language to provide instructions for the process.
The authors use the voxellearn system to naturalize the core programming language by defining alternative, more meaningful, and natural commands in terms of composition of simpler ones. Each person's creation of simple naturalized definitions could be used by others to create more complex structures.
Instead of using the traditional machine learning method of learning by demonstration, this paper proposes learning by definition, where the user can define an utterance as a series of understandable steps. Finally, the paper also proposes a grammar induction algorithm that is suited for learning from user definitions.
Let's have a quick look at some of the real-world implications of this work.
Once extrapolated to real-world programming languages, the procedure would virtually give every user the privilege of using a naturalized language in order to perform a complex algorithmic task. The process will eliminate the need for knowledge of semantics for that programming language. Now let's see how the authors have gone about building this system. The authors have created a core programming language called Dependency-Based Action Language, or DAL, which composes actions using primitive control flow. The core language is protected from any modification. The use of selection and scoping and the process of naturalization make the core language modular. On top of these, an interactive, weak supervision is provided to create an inherent learning ability by virtue of definitions. Furthermore, a semantic parser called Sempre is used for making natural language instructions formal and sophisticated. The grammar induction procedure is used to extract grammar rules from parsed definitions. Next, derivations are used to turn natural language into programs. A derivation is a process by which a user utterance is turned into a program. The authors have used various features to weigh derivations like social features, span features, etc. Finally, a community of 70 recruited users from Amazon Mechanical Turk built 230 voxel structures using this system. Thus, the community of users evolved the language to become more efficient over time in a distributed way through interaction.
Now let's look at how the authors went about evaluating the paper. The authors utilized the services of Amazon Mechanical Turk, or AMT, to build a community of users who collectively built interesting structures in voxellearn.
They divided the experiment into two stages. In the first stage, the AMT workers were asked to replicate a structure exactly. In the second, they were asked to build any desired structure within 30 minutes.
The results showed that the number of grammar rules went up to 2,817 from an initial 100. Furthermore, there was a visible increase in the usage of induced utterances for the creation of objects, and a decrease in the dependency on the core language, proving that the workers were indeed using naturalization. Finally, let's summarize what this paper has achieved.
The voxellearn setup serves as a proof of concept to demonstrate the adoption of an induced language over a core language. It enables the evolution of a more natural language that is still parsable by a computer. However, it remains to be seen if this can be extrapolated to a real programming language.
Thank you for watching this video. For more information, please visit our website at scholar.stanford.edu.